Okay, so today we're going to talk about trigonometric ratios. These are in right triangles, only work for right triangles. And there are ways for us to relate side lengths in a right triangle, to relate the side lengths to the angle measures. Okay? So without a lot of introduction here, we're just going to jump right into it, the sine, cosine, and tangent. And what we need to know first is exactly what sine, cosine, and tangent are. Okay, and you see here the definition of the sine, cosine, and tangent. First of all, it's all in relationship to an angle in a right triangle. So if I want to know the sine of angle A, and we've got a right triangle here, angle A is right here. The sine of angle A is simply a ratio. We take the length of the opposite leg and compare it to the length of the hypotenuse. So from angle A, opposite side is A, hypotenuse of course is C, and so the sine of angle A is simply A over C. Okay? That's the definition of sine, the opposite side over the hypotenuse. For angle A, the cosine is defined as the length of the adjacent side, the adjacent leg. Now, the adjacent leg is, of course, the leg touching angle A, so it's this guy, compared to the length of the hypotenuse, so B over C. And then last but not least is tangent. Tangent of angle A compares the length of the opposite side, the opposite leg, to the adjacent leg, so A over B. So if I wanted to write them out without all these words, right? So the sine of angle A would be the A over C. Just be a fraction. A over C. Okay, and so on and so forth. Now, if we turn and go from a different angle, say angle B, then these ratios take on a little bit different form. Sine is opposite over hypotenuse, so it'd be B over C. Cosine is adjacent over hypotenuse, which is A over C. And then tangent is opposite over adjacent, or B over A. So it depends on, it very much matters what angle you're doing sine, cosine, and tangent from. But they're just ratios. Sine, cosine, and tangent are just ratios. Now, I do want to point this out. In the same right triangle, the sine of one angle is the same as the cosine of another. Okay, see these ratios? They're the same. So here and here, they're the same. They just flip-flop, sine and cosine. Now, tangent from one angle to the next is just reciprocals of each other. Okay? That's the definition of sine, cosine, and tangent. They're simply ratios. They are ratios of side lengths, but we're using the angles to find those values. Okay, and we'll talk a little bit more about that in just a second. Now, let's just make sure that we can pick out the ratios themselves. Now, to help you remember this, there's SOHCAHTOA. Not the first time you're going to see this. SOHCAHTOA. Everyone in the math world knows SOHCAHTOA, or at least basically what it stands for. And this stands for the sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over adjacent. Okay, and that's going to help you remember, hopefully. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So, just right now we're going to talk about finding the ratios, okay? So in this right triangle, we've got legs of 6 and 8, and the hypotenuse is 10. If I start at angle A, and I want to write the sine of angle A, so we have to make sure we put an angle with sine. Sine of angle A is equal to the opposite over the hypotenuse, so 8 over 10. 8 over 10 is 4 over 5. The cosine of angle A, cosine ca is adjacent over hypotenuse, so 6 over 10, which reduces to 3 to 5. And then tangent of angle A, TOA, is opposite over adjacent, so 8 over 6, or 4 over 3. Okay? All right. Then you try, same triangle, try to write the ratios for sine, cosine, and tangent of angle B. You can stop the video real quick if you want, and then start it back up and check your answer. Okay. Sine of angle B. Angle B is right here. Sine is opposite over hypotenuse, so 6 over 10, which is 3 over 5. Cosine is adjacent over hypotenuse, or 8 over 10, which is 4 over 5. And tangent is opposite over adjacent, which is 6 over 8, or 3/4. Okay? So the sine of whatever that angle measure is has the same value as this ratio right here, 3 over 5. Okay? Kind of a weird concept, but that's what sine, cosine, and tangent mean. Okay? Furthermore, if I don't want the ratio, or if I don't have the triangle, I can still figure out the value of that ratio. Because here's the thing. If we go back to this, 3 over 4 is 0.75, right? If we divide it out. Now, whatever this angle B is, for that angle measure, the ratio of the opposite side compared to the adjacent side, which is tangent, will always be 0.75. It doesn't matter how small this right triangle is or how giant this right triangle is. If I take the length of the opposite side over the length of the adjacent side for this same angle measure, it's a specific angle measure, 45 degrees, 40 degrees, whatever it is. It has to be 0.75. It's just this one angle measure that ratio is going to be 0.75. If that angle measure changes by even 1 degree, then the tangent of that angle measure will be something different than 0.75. If the angle measure changes, then the ratio value will be different. But if the side lengths do not change, and if the side lengths change and that angle does not change, then the value of that ratio will still be 0.75. I don't care how big or small the triangle is. What that means is, for 45 degrees, tangent has one value, no matter how big or small. So for every angle measure, tangent has one value. Sine has one value. Cosine has one value. Which means that the value of these sine, cosine, and tangent, guys, are very predictable if we have the angle measure. So much so that your calculator will tell you what those values are. Now, down here in this next section, we don't have a triangle. We don't have side lengths. But it doesn't matter. If we know the angle measure, then we can still find the value of these ratios. Okay? You have to take your calculator to figure these out. Excuse me. In your calculator, if you take In your calculator, you should have a sin, cos, and tan button. S-I-N, C-O-S, and T-A-N. If you type into your calculator sine of 40 degrees, then you will get a value. And we don't even have the side lengths of a right triangle because it doesn't matter. Right? So if you type in sine of 40 degrees, then you should get 0.6428 to 4 decimal places. The cosine of 40 degrees is 0.7660. And the tangent of 40 degrees is 0.8391. Okay? And then go through and type these in and just hit some buttons and we can get these values. So hopefully you're doing this along with me and getting these same values. Now, if you type in sine of 90 degrees, you're going to get 1. If you type in cosine of 90 degrees, you're going to get 0. And if you type in tangent of 90 degrees, you're going to get an error. Okay, now you'll learn more about 90 degrees, 90 and bigger, 90 degrees and bigger in pre-calculus. For now, suffice it to say, we will never take the sine, cosine, tangent of the right angle in a right triangle. It just doesn't make any sense for us. Okay? So we're not going to do it. All right? Okay. Now, how to use these guys. How to use these guys. All right. In your right triangle books, you start filling in these pages. Your next page needs to be your trigonometric ratio page. Okay? And don't worry about, well, I'm going to give you a couple minutes or let you stop the video and fill this whole page in. And then we'll talk about what all this stuff means. All right. So these guys are just a reminder of what these sine, cosine, and tangent ratios are. And here's your SOHCAHTOA. Okay? Now, how do we use those? Now, one thing I didn't have you do was in your calculator, if you just hit sine equals, or just hit the sine button with nothing in there, okay, then you will get an error. All right? If you just type in sine and then equals, this is an error. And the reason why is because sine, cosine, and tangent, they need an angle. They need an angle to reference. They need an angle to use. So sine will always be, and cosine will always have angle measures attached to them. They have to. Okay? Sine, cosine, and tangent use angles, and so they have to have angles attached to them. But if that's the case, then what we know is that the sine of an angle, let's say 35 degrees, is equal to the length of the opposite side divided by the length of the hypotenuse. Those two are the exact same thing. If we had the opposite side and we had the hypotenuse, we could divide them out, and that would give me the same thing as the sine of 35 degrees. Those two are equal. They're both ratios. They just look different. Okay? But if we use that to our advantage here, if we use that idea to our advantage, then we can use sine, cosine, and tangent to help us find missing lengths. So this first example, okay, where this length is x, the hypotenuse is 10, and this angle measure is 50. Okay? then I know that for this angle, 50 degrees, I can write one of these sine, cosine, and tangent ratios. If I write the sine ratio, the sine of 50 degrees has to be equal to the opposite divided by the hypotenuse, which is 10. This fractional ratio and this trig ratio are equal to each other. They're the same value. Now, we don't know what the opposite length is, but we can find it, right? And this will be one of the few times you see me do this. But I can make this into a proportion by putting sine 50 over 1 and then cross multiplying and solving. So I get x equals 10 times sine 50. So if I take 10 times sine 50, then we get 7.7 if you round to the nearest tenth. Okay? And I used sine because x was the opposite and 10 was the hypotenuse. And I knew that from sine uses opposite over hypotenuse. That's how I determine which one to use. Okay? Now, there's a pattern that develops with these equations. The rule basically is if x is up high, multiply. If x is down low, then we're going to divide. If x is up high, multiply. If x is down low, divide. Okay? So let's try this second example down here. We've got a couple of variables in it. And we still have an angle measure. Okay? Now, from that angle, since I'm only allowed to have one variable in an equation, there's only one thing out of my sine, cosine, and tangent proportions that I'm allowed to not know. Just needs to be one. I need to know two things and not know one, if that makes any sense. But from this angle measure, if I want to find either m or n, I have to do them separately. Can't do them together. It's too many variables in an equation. Now, if I look, 39 degrees, I need sine, cosine, or tangent to go with that. Well, I know the opposite side, and I'm looking for the hypotenuse. So opposite hypotenuse is sine. And I know that that is the opposite, which is 25, over the hypotenuse, which is n. Okay? Now, this is what I was talking about before. If n were up high, I would multiply. But it's not. N is low, so I'm going to do the opposite, which is divide. And so I'm going to switch the n and the sine 39. And that will tell me to take 25 divided by the sine of 39 degrees, which should give you 39.7, which means the length of the hypotenuse is 39.7. Same thing with m. With 39 degrees, I need sine, cosine, or tangent. But now, I want to use the opposite and the adjacent, which is tangent. The opposite is 25. The adjacent is m. M is down low, so I'm going to switch these two. And so m becomes 25 divided by the tangent of 39. Which gives me 30.9. Okay, so that's how we're going to use these trig ratios. Let's stop for a second, get into your example packet. If you don't have that out, stop the video, pull it out, and then we'll get going again. Okay? Okay, couldn't get it set. In 757677 part of your example packet, there is an opportunity here for you to practice getting these ratios. Take a couple minutes. Again, stop the video, try to figure out the ratios, and we'll come back on and see how you're doing. sine of A. Sine is opposite over hypotenuse, so it should be A over C. Cosine of A. A is right here, is adjacent over hypotenuse, so it should be B over C. Tangent of B. Up. Going to change the angle on you. Tangent is opposite over adjacent, which is B over A. Sine of J. J is over here. Sine is opposite over hypotenuse, so it's J over L. Now we're going to do cosine of K. K is right here. It's adjacent over hypotenuse, which is the same thing, J over L, which is what I mentioned before. In the same right triangle, the sine of one and the cosine of the other are the same thing. Okay? And then tangent of K. K is here. Tangent is opposite over opposite over adjacent. So it's K over J. Okay? So hopefully this is making enough sense. All right? The next example. Okay, find the value of x to the nearest tenth. We know this angle. We know these sides. Take a second, see if you can't figure out which trig equation to write it out and how to solve it. And same thing with number 2 as well. When you're done with number 2, start the video back up and see if you're right. And this is what you should have come up with. Okay? Both going to use tangent, right? But from the angle, we know opposite and adjacent. So this is what your equation should look like and what you should come up with for the two x's. Okay? All right. Another example here for you. Okay, we'll worry about angle of elevation and depression later. Find the length of the hypotenuse for a right triangle. Okay, so I need a right triangle. I want to find the hypotenuse. If the acute angle measure is 20 degrees and the side opposite is 410. There's your picture. So I know the angle. I know opposite and hypotenuse. Sine is the one that uses opposite and hypotenuse. So we write the equation. It's opposite over hypotenuse. I'm going to switch the x and the sine 20 since x is down low. And divide 410 by sine of 20, which is 1198.8. Okay? All right. Now, I'm going to skip a couple of sections in your review or in your example packet and get to what's called solving right triangles. We're going to jump back into your book here in just a second as well. Okay? Now, one thing that I haven't mentioned to you yet in these notes is that your calculator must be in degree mode. Okay? Now, for most of you, that means you should see a DEG in the window of your calculator. If not, you've got to figure out how to change it. All right? But you would have known by now, if you're not in degree mode, none of the numbers that I've been coming up with, you would be coming up with. Okay? So we know how to type these in. Sine of 64, no big deal. Okay? And cosine of 78. Okay? Not a big deal. But what if you don't know the angle measure? Right? What if you don't know the angle measure? for example, what if I knew that the sine of some angle A was equal to, okay, so what if in this right triangle, from angle A, the length of the opposite side was, say, 10, and the length of the hypotenuse was, say, I don't know, 20, okay? We want to find the sine, we want to know what this angle is, right? Well, I said before that sine, cosine, and tangent, they need an angle measure. If they don't have an angle measure, then we can't use it, okay? But we know that when we're solving an equation, there's got to be some way to get the variable that we need by itself. And we always use inverse functions to do that. The inverse of addition is subtraction. The inverse of multiplication is division. Well, the inverse of sine. So I'm going to have to rip this sine off of this angle. The inverse of sine is quite cleverly called inverse sine. And it looks like this. Sine to the -1 power is what it looks like. It's not what it means, but it's what it looks like. Okay? So if I take the inverse of a function, we know that, for lack of a better term, they cancel each other out. But if I inverse sine the left side of this equation, I have to inverse sine the right side of this equation. So I'd be left with angle A is equal to the inverse sine of 10 over 20. Now, we know that 10 over 20 is simply a decimal. It's 0.5. That's what we would type into our inverse sine. Where regular sine, cosine, and tangent need an angle measure, inverse sine, inverse cosine, inverse tangent need a decimal or ratio. And they need a ratio value, either in the form of a fraction or in the form of a decimal. Either one, it doesn't matter. So if I take, for most of you, you're going to find the inverse sine right above your sine, cosine, and tangent buttons. Okay? And so you're going to want to use that. So you're going to want to hit inverse sine of 10 over 20 and close your parentheses when you do that. And if you type that in, then angle A is going to be 30 degrees. Okay? That's how we're going to use inverse to find angles. That's how we're going to use trig ratios to find angles. All right? Now, quite simply, we can change this over to the next page in your book. This is kind of fuzzy. I apologize for that. But basically, we're going to talk about solving right triangles. Solving right triangles means finding all the angle measures and all of the side lengths. Okay? And it just depends. It depends on what we're missing. It depends on what we need to go find. Okay? So, some things you want to keep in mind when you're solving right triangles. If I know the angle measure, I have an angle measure to put into sine, cosine, and tangent. I'm going to use regular sine, cosine, and tangent. They need an angle measure. Okay? Okay, if I don't know the angle measure, then I'm going to have to use inverse to get those guys, to get the angle measures, right? I have to use the inverse to get the angle by itself and to find it. Okay, now as a quick example in your notes.
Hey, we got it.
So a quick example in your notes, we have this triangle where the side lengths are 65, the legs are 65 and 72, and the hypotenuse is 97. Now it says find C. We can find angle A as well using the same thing. Right? So here's what I'm going to do. Here's angle C, and I need one of my trig ratios, and it doesn't matter which one. I know all three side lengths, so all I got to do is pick two of them, right? We can use the adjacent and the hypotenuse, and I know that cosine uses adjacent, which is 72, over the hypotenuse, which is 97. But I have to rip this cosine off of this C to get C by itself. And so I'm going to inverse here, and I'm going to inverse here. So that C is equal to the inverse cosine of 72 over 97. So I divide out 72 and 97. I hit inverse cosine, and I get 42.1 degrees. Now, same thing for A. I know opposite and adjacent, so let's say we can use tangent. Opposite is 72. Adjacent is 65. I'm going to use inverse tangent to rip that tangent off of this A. Now I take 72 divided by 65 and hit inverse tangent, and I get 47.9 degrees. Okay, which makes sense because A and C have to add a 90, and they do. So that's how we're going to use inverse sine, cosine, and tangent. Now, back into your example packet, we can put this to use. Okay, I'm going to skip a couple more examples again and get down to this last one. There's a triangle above that they want you to use as a picture. Okay, and so I'll redraw it here so we can reference it. Here's your right angle, and let's see, this is y, this is x, this is z, and they say the angle y is 17.4 degrees, and z, which is the hypotenuse, is 12, and they want us to solve this triangle. Now what that means is that we need to find the three angle measures, angle x, angle y, and angle z. And we need to find the three side lengths, and they call them little x, little y, and little z. Okay? Now we know some stuff already. We already know that z is 90 degrees. We know that y is 17.4, which means that we can find x really quick. If we just subtract 17.4 from 90, then we'll get x, because the two acute angles in a right triangle need to be complementary. Okay, so this is 72.6. Piece of cake, no problem. It's the other sides, because z is the side opposite angle z, which is the hypotenuse, is 12. It's the other two sides, x and y, that we need to go find. Okay, so this is little y, this is little x. If I want to find y, I know this angle, angle y, so I'm going to use opposite and hypotenuse to get y. So I'm going to use sine. Sine uses opposite and hypotenuse. Okay, since y is up high, I'm going to multiply. I'm going to get 12 times 7 sine of 17.4, and y ends up being 3.6. Now to find x, we're going to do the same thing, only now x is the adjacent side in the hypotenuse, so that's cosine. So cosine of 17.4 okay, I need to move this over probably. Is equal to x over 12. Since x is up high, yet again, we're going to multiply 12 times cosine of 17.4. And so we get 11.5. And there, we've solved the right triangle. We have all angle measures, all side lengths. Okay? Now, this is very quick. Hopefully that makes enough sense. We can reinforce anything in class next time. Okay?